curvilinear motion, which is part of the dynamics. Already we have learned what are the variables in rectilinear motion. First of all, what is the basic difference between curvilinear motion and rectilinear motion? Whenever a particle is moving along a straight line, it is considered as a rectilinear motion. And when a particle moving along a curvature performing a circular path, then it is considered as curvilinear motion. In rectilinear motion, either the motion of the particle will be along horizontal direction or vertical direction or along a particular line. Means, for example, if particle starting from point A is moving towards the right direction for a particular distance from t equal to 0 to t equal to t, slowly this particle is changing its position, moving towards right. In this case, if we will describe the motion of this particle A in coordinate system, only x coordinate is changing. Assume that if reference axis is x and y, the reference axis coefficient is given. So we can see that the particle moving along its line, moving towards a rightward, the coordinates at all the points is changing only for x. If here the value of the coordinate is 2, here 4, 2, 4, 6, 8, then at each point the y coordinate of the particle, the position is constant, and there is change only in x. Similarly, if another particle B either moving in upward direction, we can say that here when particle is moving in upward direction along a line, only y coordinate is changing for the position, x coordinate remains constant. From this example, we can conclude that in rectilinear motion, if some reference axis is fixed, that displacement is only in a single direction, or the position of the particle is changing only in a single direction, and we know that the change in displacement for particular time, a change in position for particular time is displacement. The rate of change of displacement is velocity. So, when the displacement is in single direction, the velocity is also acting in single direction. Velocity is directly interrelated with displacement. Displacement is in x direction, that's why velocity is in x direction. And if velocity is in x direction or in a single direction, then ultimately the acceleration of the particle is also in single direction, because acceleration is rate of change of velocity. Displacement, velocity, acceleration, they are interrelated with each other. One quantity is in single direction, then ultimately other quantities are also in same direction. They will not change the direction of the direction and along a line on which particle is moving. In both the cases, if displacement is in y direction, already we have seen the motion under gravity. In that we are considering only the vertical direction, movement along the vertical direction. So acceleration becomes acceleration due to gravity. But this displacement is always in vertical direction. Whether it is velocity, it is also in the direction in vertical direction. And acceleration is ultimately in the case of the motion under gravity, the acceleration becomes acceleration due to gravity, which is always acting in vertical direction. So in general, in rectilinear motion, the displacement, position, velocity, acceleration are along the same line, and ultimately the other coordinate becomes 0 because there is no change. But in curvilinear motion, what is actually happening? In curvilinear motion, assume that it is the center of the curvature of the path about which the particle is moving from position A, B, C, D. And if we will decide the axis X and Y, then you can see from the motion of this particle that for each time frame, both coordinate X and Y are changing. X and Y are changing. What it means? It means that during the curvilinear motion, X coordinate and Y coordinate both are variable. Both are variable. Means a curvilinear motion is a combination of the motion along two directions. It is a combined effect of horizontal displacement and vertical displacement. It is a combined effect of horizontal displacement and vertical displacement because the position of the particle is changing in both the direction, horizontal and vertical. Horizontal and vertical. So in curvilinear motion, as this curvilinear motion is having variables in two directions, that's why we have to consider the velocity in two directions, acceleration in two directions, and displacement if direction is decided accordingly with reference to axis, we have to calculate the displacement of the object. So to describe the curvilinear motion, there are coordinate systems. So we will see the first coordinate system, which is called as rectangular coordinate system. First coordinate system, which is called as rectangular coordinate system. Rectangular coordinate system. This system is very simple, as it's composed of our general coordinate system X and Y. Means assume that a particle is moving from position A to B, performing a curved path, moving along a curvature. So the position of this particle can be described with the help of the position vector r bar equal to xi plus yj, where I and j are, we know that a vector we already learned in earlier classes. I and j are unit vector in x and y direction respectively, and x and y are the coordinates of the unit vector. So the position of the particle is, we can write the position of the particle is given by xi plus yj, and we know that the rate of change of position is displacement. Position for particular instant of the time is xi plus yj. If I need to find the velocity with the help of this vector, then velocity equal to rate of change of position dr by dt. I will put here the value of r d by dt of xi plus yj. Therefore, velocity v equal to dx by dt I plus dy by dt. What is this dx by dt? dx is horizontal displacement. X is horizontal displacement. This dx by dt is horizontal component of the velocity. Horizontal component. by dt is vertical component of the velocity. And horizontal and vertical components are perpendicular to each other. This equation I can write here v equal to vxi plus vyj, where vx is equal to dx by dt and vy is equal to d by dt. As we know that in rectangular coordinate system x and y are perpendicular to each other. If I require to find what is the magnitude of velocity v, then whenever two vector quantities are perpendicular to each other, vx square plus vy square, v equal to vx square plus vy square. If direction is required theta v, then it is tan inverse mod of vy divided by vx. Tan inverse mod of vy divided by vx. So with the help of this, we can find the direction of the velocity as well as magnitude. Direction we will get from this formula theta v equal to tan inverse mod of vy divided by vx, and magnitude we will get from v equal to root of vx square plus vy square. Similarly, if I require acceleration a bar equal to, it is already known to us, dy by dt. V is what? V is d by dt of vxi plus vyj. Therefore, we will expand it d by dt of vxi plus dvy by dt of j. What is this? It is the horizontal component of the acceleration. Horizontal component of the acceleration. Why? Because the rate of change of velocity is acceleration. This equation will be modified as a bar equal to axi plus, similarly dy by dt, dvy by dt is derivative of rate of change of vertical component of the velocity. That's why it is vertical acceleration, ay. The equation of acceleration is a bar equal to axi plus ayj, where ax is equal to dvx by dt and ay is equal to dvy by dt. Horizontal component of acceleration and vertical component of acceleration. If I require total magnitude of the acceleration a, then we know that ax square equal to ay square. This is the formula. So, in brief, in rectangular coordinate system, velocity v is given by v equal to dx by dt I plus dy by dt j, where dx by dt is horizontal component of velocity, dy by dt is vertical component of the velocity. If magnitude is required, v equal to the root of vx square plus vy square. If direction is required, theta v is equal to tan inverse vy by vx. It must be involved. We know that the acceleration is rate of change of velocity, so a equal to dv by dt. But from equation 1, we will write equation 1. From equation 1, v is vxi plus vyj. I will put here d by dt vxi plus vyj. I will differentiate dvx by dt dvy by dt. This is the rate of change of horizontal component of the velocity, which is horizontal component of acceleration ax. This is rate of change of vertical component of velocity, which is equal to vertical component of acceleration. If I require magnitude of acceleration a equal to root of ax square plus ay square. These are the important formulas. We have to remember v equal to dx by dt I plus dy by dt j, v equal to vxi plus vyj, v how to calculate the magnitude. All these formulas are very important. Rectangular coordinate system is very famous, very easy. If one variable is given, then we can easily find the other variable with the help of these formulas. Depending upon the conditions given in the problem statement, we have to consider the formula and accordingly we have to apply it. It is very simple. If acceleration is given in horizontal and vertical direction, either in one direction or two direction, and velocity need to find, then for finding the velocity, I will integrate the equation of acceleration. If velocity is given, displacement I require to find, then I will integrate the velocity equation, so I will get displacement. Reverse, you can think, if displacement is given in x and y direction and we need to find the velocity in x and y direction or combining the magnitude of velocity, then I will take derivative of displacement equation. Then after the differentiation, I will get the equation of velocity. From that equation of velocity, if again I will take differentiation, it will give you the equation of acceleration. These are the connectivity. If displacement is given, differentiate it, you will get velocity. Velocity is known, differentiate it, you will get the acceleration. If acceleration is given, we require velocity, integrate it. Velocity is known, we require displacement, again integrate it. So in rectangular coordinate system, it is very easy to understand. Now there is another coordinate system that is called as normal tangential system. Normal tangential system. In normal tangential system, we are describing the position of the particle along normal component and tangential component. And this normal and tangential component system is applied whenever the path of the moving particle along a curved line is known. The path of the path of the moving particle along a curve is known. Means we can describe path is known, then we can describe the position of the particle for particular instant in terms of its normal component and tangential component. It is very easy. Means we will split the vector in normal direction and tangential direction. Normal direction and tangential direction. But you can see that if for particular instant path is known, always the object performing for object moving is in tangential direction, because the direction in which the displacement is taking place, it is in tangential of that velocity for that instant. Means here you can say, here I will draw the tangent, there is no movement in normal direction towards the center of the curvature. Towards the center of the curvature. Right? We will, at all the points, it is in tangential direction. At all the points, it is in tangential direction. That's why the velocity in tangential direction, is velocity itself. Again, everybody. Means in normal tangential direction, the velocity is always in tangential direction. Means whatever the component in tangential direction, it is always equal to total velocity of the object. Total velocity of the object. And Vn, the normal component of the velocity in that case, is 0. The normal component of the velocity is 0. No need to resolve in this case. If you know the if I know that what is the value of velocity in what is the value of the velocity? It is always equal to tangential velocity, because in normal tangential component system there is no displacement in normal direction. That's why the component of the velocity in normal direction is always zero. Always zero. Vt equal to v and Vn equal to 0. Same, if we will go for the acceleration, we know that the acceleration of the particle is rate of change of velocity. Therefore, if I want to find the tangential acceleration at, then it must be equal to differentiation of tangential velocity dv by dt. dv by dt. But this tangential velocity is velocity itself. Therefore, at is dv by dt. At is dv by dt. It is very important formula for finding tangential acceleration. But student can say that as normal component of the velocity is 0, therefore normal component of acceleration is also 0, but it is wrong. It is not 0. You will say why? We know that there is one mathematical expression to get the value of formula for component of the normal acceleration, but I will not go for that expression. I will just what is the concept behind that? We know that whenever a particle is moving along a curvature, means moving along a curved line, there are some forces which are acting on the object. The very important force is centripetal force, and another very important force is centrifugal force. And centrifugal force is given by F centrifugal Fc equal to mv square by r. mv square by r. What is this v square by r? It is the acceleration. Because according to Newton's second law of mathematical expression, F equal to ma, and this a is equal to here v square. A is equal to v square by rho. It is acceleration, and this acceleration we know that the centrifugal force is always along the center of curvature, and the component of the acceleration which is acting along the center of curvature is normal acceleration. That's why here am equal to 0 is wrong, and we have to consider value of centrifugal acceleration v square by rho. Why rho? Because in so many mechanics books you use rho instead of r, the radius of the curvature. So to have simplicity, or to avoid the confusion, I am also using the rho. An equal to v square by rho. It is the formula for normal acceleration. Apart from the mathematical, there is a mathematical expression to obtain the value of this n equal to v square by rho. But from the concept, we can understand from where this value an equal to v square by rho. So now the acceleration has two components. One component, first component is at, and second component is an, and both have the values. So if I require total acceleration a, then it must be at square plus an square. At square plus an square. These are the important formulae for normal tangential coordinate system. It is very easy. If velocity is given for a particular instant, then it is a tangential velocity, because the normal component of the velocity is 0. Vn equal to 0, Vt equal to v. Acceleration A as two components, that's why we have to split the acceleration also in normal and tangential. At equal to dvt by dt, but Vt is V itself. Vt tangential velocity is velocity itself. That's why the formula will become At equal to dv by dt. At equal to dv by dt. And An, normal component of acceleration, is v square by If I require total acceleration, then total acceleration equal to At square plus An square. Where normal and tangential force system is required, whenever in problem statement radius is required to find, then you can use this expression, because in rectangular coordinate system the radius which we are mostly in the r of the rho. Radius is, there is no formula in which rho or radius is present. All are interrelating that with horizontal component and vertical component. But when radius is required to find, or we have to use the value of the radius, then you can use this formula, An equal to v square by rho, where rho is, again I will write here, where rho is, this rho is radius of curvature. Radius of curvature. You can use the r, but to avoid the confusion, I am also using the same notation as number of books are using. N equal to v square by total acceleration A equal to under root of At square plus An square. These are the very simple formulas, and depending upon the conditions given in the numericals, we have to use the formula. We will see the numericals on rectangular coordinate system, normal tangential coordinate system next lecture. It is very easy.